and welcome back to another episode. Episode 13, I think, if I've counted off correctly. Alright. This will be our first not streamed episode, because for some reason OBS is failing to connect to Twitch, and I've not got a lot of time this evening, so I'm just going to record this one for posterity. So I don't think it's going to be a very long stream. Well, it's not a stream at all, but it wasn't going to be a particularly long stream. I left the last video off with me failing to get the screen resizing working. So if we nip back to the project, and we'll just run it quickly, we can see that if I resize the screen, oh, there we go, that it's hanging, right? We can see that it's running perfectly fine. It early returns, it finishes that draw, and then the next draw hangs. And just like with the last issue where I got stuck almost immediately after stopping the stream, I think I solved it. There's something interesting in there about how like your brain works. Almost like that once the pressure's lifted, immediately you can see what you're doing better. So maybe that's a bit of a skill I need to work on, is recognizing you're stuck and sort of taking a bit of a breath and a step back. But hey ho, live and learn. So my hope today is we get that fixed, and if I do that reasonably quickly, I'll try and get the index buffer stuff set up, because I don't think that's particularly complicated. And then we can do an indexed draw command. And I think that's most of the stuff off our updated README. Right, then we'll have handle screen resizing done, our index buffer stuff done, and we can do blending and texturing in a week or so's time, because I'm off on holiday after this one. So let's aim to leave it off somewhere pretty neat. I'm not planning on doing any of this work while on holiday, because I don't think I'm going to get a bit of time to record a sensible video, and I'm enjoying having the whole process in the videos. I think that if the videos have any sort of value in them at all, I think maybe it's in the showing a sort of realistic picture of what this has been like, warts and all. So let me just kickstart my stuff. What do I normally do? I make a TMUX server, then I make a Cocoon server. We cack into there. We're in renderer, and if I jump down to here, this was the place where we had an issue. Let me just bump the size slightly. So I think the problem is, when we have our early return, it's after we've reset our fence. So if I actually jump back to draw frame, where am I looking? We have our handle screen resized function. Then deeper in here, we have our step where we wait for our fence to make sure the previous frame is finished rendering before we start rendering this frame. That has succeeded, and we've reset the fence. So now our fence is in an unsignaled state, and the next frame won't start rendering until the fence is signaled, which it will never do if we hit one of these early returns, because, well, we've returned out, right? Our fence gets signaled down here, much further down. Where would it be? All the way down on the queue submission. Which I guess is after. Okay, so one of the early returns, I guess, might still work. That's an interesting thought. But certainly the acquire image one, if we early return out of that stage, then the whole thing just breaks. And so I think the simplest fix might be to come in here and change. Can I do, or can I remember how you do? There we go. So instead of early return, we're just going to say a swap chain out of date / suboptimal on QPresent. So there is no early return now. And let me go find my other early return. take out the return, and again in here we'll say grab this, and we'll say swap chain out of date or suboptimal on acquire next image. And if my guess is right, that means then down here in the handle screen resized, we should fix this problem, right? Because we no longer early return out. I guess it'll attempt to draw something. As we'll see, if something does fall over, everything that errors unexpectedly crashes the program, so it'll be very obvious if something unexpected happens. I think what we'll see is a frame or two that's weird, then GLFW will pick up the fact that the screen is resized, we'll hit our resize logic, and hopefully everything updates sensibly, but importantly, we never have the chance of hitting the state where our fence is left unsignaled forever. So let's just test that out. So we can see it's happily drawing, and we can resize it. Beautiful. And we can chop and change the screen around, and we can make it really tall and really short. So yeah, that looks solved to me. Cool, I thought so. Nice. Okay, I think we might have a bit of tidying up to do then. So, for one thing, we've got a whole lot of printing happening. I'll tell you what, I'll do the same thing I did last time. I'm pretty tired again today, so I'm anticipating this may be a bit of a messy one. So we will commit early and often. So let's just say in here, work in progress, resizing, resizing window fixed, but debug mess everywhere. Right, let me just check what other to-dos I have. So that's still a to-do, and that's our only to-do. Okay, that's pretty nice. Can we find other format print lines? Should we keep this print line? I might just comment it out, because it might be a useful nudge if we're debugging. That's a point. Probably at some point we want to set up some sort of like actual logger situation so you can turn on logging and get stuff that's useful to us. But hey, let's leave that for another day. Things aren't that complicated yet, right? We don't need to report that anymore. I'm going to take the same tack here. I think we might have another bit of logging in here. We do. So we can clear that out. We added that for logging's sake as well, so we can clear that out. And then if we go and run, do we have a load of messages popping up? Let's go. So we can catch all of the screen resizing. That'll be in our callback down here. What are you saying? Yeah, so you're just doing that. So let's try again, and we should just see it quietly work. Cool. That's pretty neat. Yeah, I told you that'd be quick. So now we've got that done. Let's, I guess, just jump back in here, check our thing right at the bottom is neat as well. Or is there anything in this that we wanted to sort out? Is that device wait idle necessary? I'm going to keep it because I think it can't hurt. I'm not sure though. Okay. We'll leave it. It is working. It's not hurting anything. I think I had a comment that I left somewhere that was like, do some destroying. It's not that one. It's not in there. This. Do we care? I don't think we do, so let's just get rid of that. And I think that's our tidying done. So let's just say in here, tidying. Nice. Right. And I think we're then ready to go and try and set up our stuff for the index drawer. So if I go and grab Ocular, and we can go and grab the draw commands, 22. So you know you've been looking at this too much. Is any of this useful? Then look at. I think somewhere in here there's a little thing that's like there are two types: draw commands, and there's the indexed ones and the not indexed ones. Although maybe this is a silly way to find it. Yeah, it probably is. Okay, let's have a search instead. So if I go for command, I think it's draw indexed. There we go. There we go, there's the list. So this is the one we're currently doing, is just VK command draw. I think if we jump down to VK command draw indexed, it should look an awful lot like command draw, which is not in there, it's in the renderer. Command draw. So currently we're passing in a command buffer, vertex count, instance count, first vertex, first instant. And this one will take an index count instead of a vertex count. The instance stuff I think we can ignore as well, and the vertex offset is only needed if we're using the same vertex buffer for multiple different things, but we've only got the one thing, so I think we just set that to 0. So before we can do that, clearly what we need to do is go and set up a index buffer. I think a sensible place to start is back all the way up at vertices. We'll make indices. I'm gonna guess your U32s. First index, vertex offset. But I'm not entirely sure of that. I'm sure they're numbers, right? I think that they're numbers. I'm reasonably sure they're going to be unsigned numbers, because I think what they are is basically they're indexes into our vertex buffer. So if I have the vertices that I have there already, then what we can do is we can delete our repeated ones. So ignoring the fact the colors are different, let's imagine that we didn't want the different colors. This one is that one repeated, right? So we only need the one of those, and that one is that one repeated, so we can get rid of that. And then we can clear out these. I might leave comments just to remind myself. So this one is minus 0.5, minus 0.5, so that's top left. Minus 0.5, 0.5 is bottom left. That is top right. And so that one is bottom right. So there are vertices. Then in here, we're going to have triangle 1, which will be a list, and we'll have triangle 2, which will be a list. And triangle 1 will go 0, 1, 2, I think. Right, let's just check that's going the counterclockwise, I think we're doing. So top left goes down to bottom left, up to top right. And then the magic here is that this triangle can share some of those points. So does it matter which way around it goes? Let me do 1, 2, oops, 2, 3, I think. So you go bottom left, goes up to top right, down to bottom right. That's going clockwise. So maybe it's actually 3, 2, 3, 1, 2. 3, 2, 1. Oh my god, hang on. Have I got a drawing thing? I have got a drawing thing. So we've got 1, 2, 3, 4 points, and they are top left is 0, bottom left is 1, top right is 2, and that is 3. So our first triangle goes 0, 1, 2. So we go 0 to 1 to 2, and then it'll come back to 0 because it's defined as a triangle list. And so that way around is counterclockwise. So we need to do the same way around. So I guess if we do 2, 1, 3. Right, so we go 2 down to 1, 1 across, then coming up this way. Why are you jumping around like that? So that is wrong. Let's do 2 to 1 to 3. I think that represents the same object, essentially, with our two triangles. And the reason it's preferred is we're not having to repeat that vertex data, because you can see our vertex is a bigger object than these are, so it's more efficient use of memory. Probably not a big deal on the scale that we're working at, but I don't know, it's how the other things I've worked on worked, so I'm going to do it because I don't think it hurts. So we've now got two things. We're going to need to make ourselves another memory mapped buffer in our renderer. So we're going to do the same thing that we did for our vertex buffer up here. Except for our index buffer. Now, is it worth pulling this stuff out into a function? Vertex buffer memory, copy vertex data into vertex buffer. And then that's all different. Okay, so let me come in here and do like copy start and copy end, just so I don't get too mixed up. And we're going to go back by paragraphs until we hit... No, I've missed it there, haven't I? Come down. So if we copy all of that, jump down to there. Right. And then we want to adapt all of this to be index stuff. So instead of vertex, you are going to make an index buffer. Any of this depend? Yes. Do I need to be careful about that type? I think we're just going to not be. If it blows up, it blows up. This usage is clearly going to have to be different. So we're going to have ourselves an index buffer. Sharing mode exclusive for all the same reasons. Creates a buffer with that. And this one will not be saved on the vertex buffer. So instead, we're going to reproduce these. Fubber. So we're going to have ourselves index buffer is a VK buffer. Index buffer memory is a VK device memory. And index buffer memory mapped is a raw pointer. So, just pausing to wonder again, is it worth trying to pull a function out for buffer creation straight away? I'm going to stick with no, only because I can only think of the vertex index buffers as places we're going to need to do this for now. So, yeah, we'll call it rule of 3. We'll pull a function out if we do another one, but I don't think we're going to, at least not for a while. It does mean, though, we're going to have to be a little bit careful about not overwriting things that we don't mean to. So create index buffer, creates buffer, sticks it on the index buffer, and then in here, gets index buffer. Allocate the vertex buffer memory and bind it. It's now going to be index buffer. Need to get the memory requirements for the index buffer. Then it will grab the physical device memory properties, desired memory type properties is going to be the same. We have a bit of messiness in here that I don't remember very well. I think it's just checking that the memory type that we want is supported by a heap on the available device. Allocate memory info. Takes all of that stuff. We then allocate memory, which will go into there. And that one will say index instead of vertex. Then we bind the buffer memory to it, or otherwise it doesn't know what memory it's actually like using. Well, it doesn't know anything. It's a computer. It won't be associated with the memory we just allocated. So we want to associate that buffer with the index buffer memory, which in here will be index buffer memory, which means that we have index buffer memory, do the whole size, oops, go to there, index buffer memory mapped. So that gives us a persistent memory mapping, so we can copy data into it. Copy the index data into the index buffer. Intrinsics, we do a non-overlapping copy. Destination is the index buffer memory mapped. We're going to have indices, which is just a global variable at the minute. This is just going to be size of U32, which isn't being very careful, but should work. And then that's our lot. So if we now nip up to there, hopefully we run and it's fine. Yeah, so that is expected because we've gotten rid of our other vertices. So yeah, that's not a problem. No validation errors on closing it. So at this point we've made our, what's it called? Is there anything in this that uses the vertex buffer? Doesn't look it, does it? Or did it just go from the top? Bind vertex buffers. So I think we're going to have in here something like vk command bind index buffer. Excellent. And then we're going to have in here vk command draw indexed. And all of this, oopsie daisy. Not got the hang of this yet, have we? So we go to there, we extend to there. I need to set up a thing for, like a shorthand for commenting. So command draw indexed will take in a command buffer, a index count, which it will be cast U32 len indices, similar to what we did before. Our instance count will be 1, our first index will be 0, our vertex offset will be 0. So hopefully that works. And we can jump back here to command bind index buffer and just check if there's anything useful to know in there. Aha, okay, so you can choose the size and it will be defined. Oh, hang on. Where's that number 2? There we go. And so you come up here and you take a command buffer. Is it a bit lazy to not put these in? They do make it more readable, don't they? Alright, I'll tell you what, we'll do it quickly. I think future me that is back here debugging will be thankful for them. So we'll have instance count, first index is equal to that. Vertex offset needs to be 0 because we've only got the one set of meaningful data in our vertex buffer. Oh, I balls this up. Index count is that. First index is that. Vertex offset is that. First instance is that. So what are you? Command buffer, index count, instance count. First index. So the first everything is 0. Instance count is 1. We may have just saved ourselves a headache there. Right, and then we'll do the same here. So command buffer is equal to renderer.command buffer. Buffer will be renderer.index buffer. Our device size, the starting offset in bytes. Okay, so offset will be equal to 0. So offset is starting offset in bytes within buffer using index buffer address calculation. So yeah, we start at the start. And then index type to VK index type. Cool. Yeah, so we're using uint32, which again I think is probably unnecessary. I guess the only limitation is the smaller the type you use, the less like renderable things you can represent with this one index buffer. So we're just going to pick the big number. So we shouldn't ever bump up against it. And we run. And it works first try. Don't you just love when that happens? And we bounce it around a few times. We make it big, we make it small, and it all works. We close the program, and it works. Excellent. Cool. Right, so we don't need that now. And again, tired. So we're going to commit early and often. Take the whole lot and say here index buffer and index draw. Beautiful. Let's drag you back a little, it's bothering me. Okay. Is there anything else I was going to do? I was going to have a quick look here. We've not added anything to dinit. And we might as well, right? So basically everything that mentions vertex in here will have a corresponding index buffer thing. These calls are very samey, so there's nothing to look up, I don't think. So we'll destroy the index buffer. We will renderer.index buffer memory mapped is nil, because again, just for sense checking that we don't hold on to a pointer that ends up being meaningless when we do this thing. We unmap the memory from device and index buffer memory. We free the memory on the device for index buffer memory. Cool. Let's write all, run it again, check it resizes okay, and it does. Right. Check it closes okay, and it does. So let's have a tidy up memory. Let's tidy up index buffer resources. Cool. I think that might be everything I had in mind for this. Not sure actually how long we've been going. Only about half an hour. I did say it was going to be a short one. I'm slightly surprised how quickly that all went through. That all felt very painless. Maybe I'm improving. maybe I just got lucky on something very simple. Right, yeah, let's just say readme to-dos updated. Nice. And I think that's where we're going to leave it. Like I say, there's more stuff on our to-do list. We want to enable blending still. We want to add texture images and sampling so that we can start actually building out our game. But it's getting exciting, so I think that might be the point where we're done building out a renderer and we can start actually building the game. I don't know if this has been interesting. I guess I've tried to pitch these videos like I was making things that I would want to watch, and I know that I would like to watch somebody build a renderer, even a very simple 2D sprite renderer from scratch. So that's what I've been up to. This is all something I've done a couple times before, so this has felt more like an exercise in, I guess, really hammering home the Vulkan API details that I'd half learned, half forgotten. Once we get onto actually building the game, there's a bunch of stuff in there that'll be actually pretty new to me. So yeah, I think it's been fun so far. I think it starts getting more exciting once we get past this though. So looking forward to it. But we have to leave that all for now. So like I say, I'm off on holiday for a week, so this will be the last I touch of this for a while. I guess if I do any other programming, I will mention it when I get back, but I'm not planning to touch this because I won't be able to make any videos. So I will pick this back up with you in a week or two's time. Thanks for joining us, and I'll catch you then.